Students, welcome back to the Algebra 2 CST review questions. This is part 3. We're going to be going over questions 41 to 60. Remember that this document is available online using this URL www.cde.ca.gov/ta/sr/css05rtq.asp, or you can simply Google Algebra 2 CST release questions and the second link, follow it, and then you gain access to this document right here. Okay, so let's go ahead and start with question 41. It says Jenny is solving the equation x squared minus 8x equals 9 by completing the square. What number should be added to both sides of the equation to complete the square? So one thing you want to remember is anytime you hear completing the square or complete the square, you need to use b over 2 square. Okay, that's what you always use to complete the square. Alright, so in the equation x squared minus 8x equals 9, b is basically negative 8. Okay, so if you add b over 2 squared to both sides, that will make it possible for you to complete the square on the left side because you create a perfect square trinomial. Okay, so b is negative 8. What you do with that is you divide it by 2, because you need b over 2, which is negative 4, and then you gotta square it. Okay, you gotta square it. So when you square negative 4, you get 16. So this is what you add to both sides to complete the square. So your answer is D. Alright, let's move along to question number 42. 42 says two consecutive positive integers have the property that one integer times twice the other equals 612. What is the sum of these two integers? So 42. So let the first integer with the first be x. So what does consecutive mean? Consecutive means that they differ from each other by 1. So like 3, 4, 5, these are consecutive numbers. If you keep adding 1 to get the next one. So if the first is x, the second is automatically going to be x plus 1 since they're consecutive. Okay, so using the property here, it says one integer times twice the second equals 612. So x times twice the second, x plus 1, that's the second one, equals 612. So if we solve this equation, we'll find out what the first one is, and we'll add both of them together, and then that will be the answer that we need. So we're gonna have, let's do this. So we have x, let's distribute the 2 first. So we have 2x plus 2 equals 612, and then distribute the x, you have 2x squared plus 2x equals 612. Since everything is even or divisible by 2, I'm going to go ahead and reduce this quadratic equation by dividing everything by 2, okay? So that gives me x squared plus x equals 306. Alright? Now, in order to solve this with whatever method I like to use, I need to put it in standard form. Okay, so the standard form basically requires you to put this equal to 0. So I subtract 306 from both sides. Subtract 306, subtract 306. So you're gonna have x squared plus x minus 306 equals 0. Now let's solve this by using the x game. Okay, I'll use the x game factoring method here. If it doesn't work, then I have to resort to the quadratic formula. Okay, so AC goes on top. AC is negative 306, and then B is 1, because the coefficient here is 1 and coefficient here is 1, 1. Okay, and then that's your A, that's your B, that's your C, just like you're doing the quadratic formula. Okay, so what two numbers multiply to give you this and add to give you that? I have no idea. So what I'm going to do is I'm going to advance to break down, I'm going to proceed to break down 306, okay, and then we can see how we can group them to get numbers that can combine, either add or subtract to get 1. Alright, so I can take out 3 from this because I know 3 goes into the sum, which is 9. The sum of the digits, 3 plus 0 plus 6 is 9, so 3 goes into 9. So 3 has to go into 306. It goes in there 102 times. And then let's see, 3 also goes here again, because 1 plus 2 is 3, and 3 goes into 3. So 3 goes here 3, 34 times. And then I can take 2 out of here. 2 goes here 17 times, okay? So let's see. What if I group these 3 numbers and then the last one? 3 times 3, 9 times 2, 18. 18 and 17 is one combination. Can I give me 1? Of course. So that's what a coincidence. That's a pair I want. Okay, so 18 and negative 17 should give me this. Alright? Alright, so if I put it in, I'm going to have x squared plus 18x minus 17x minus 306 equals 0. Factor by grouping, take out the x, we have x plus 18 minus, take out the 17. 17 goes there 18 times, so 18 equals 0. Alright, if I take out a minus, this has to switch to a plus because minus times plus is minus. Factor out the x plus 18, and you're left with x minus 17, okay, equals 0. So the question says 2 consecutive positive integers. So let's solve this first. Using the zero product property, if the product of these 2 numbers is 0, either the first is 0 or the second is 0. Alright, so let's solve this. So for the first one, you subtract 18 from both sides. And then you have x equals negative 18. And then this one, you add 17 to both sides. And you have x equals 17. So the one that's positive is the one we want. This one, forget this one. This is negative, so this can't be an answer. So this one, x equals 17, okay? Alright, so we have the first one. If the first one is 17 and they're consecutive, the next one must be the second number, x equals 17. The first number is 17, so the second number has to be what? Second number is 17 plus 1, which is 18. So the question asks for their sum, so what we just do is just add these 2 numbers. If we add them up, we'll get 35. So our answer for this question is B. Alright? Okay, let's move along. Moving along to question 43. It says, what are the solutions to this equation? To the equation x squared minus 6x plus 5 equals negative 8. Before we start, let's put it in standard form, make it equal to 0. So we add 8 to both sides, and that gives me x squared minus 6x plus 13 equals 0. So in this problem, question is, can I use the x game to figure this out? Let's try it out. So AC goes on top, AC is 13, and B is negative 6. So what, what 2 numbers add to give you negative 6 and multiply to give you 13? The only combination I can think of is 13 and 1, and that doesn't work. So guess what? This expression is prime, so we cannot factor it by grouping. So we have to resort to the quadratic formula. A equals 1, B equals negative 6, and C equals 13. The quadratic formula, which you should know, is x equals plus or minus, x equals negative b plus or minus the square root of b squared minus 4ac, and then the whole expression divided by 2a. Okay, so we're going to use these values of a, b, and c. We're going to put them into this equation right here and generate our results. Okay, so let's go ahead and do that. So we're going to have x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13 divided by 2a, which is 2 times 1. Okay, so that gives us 6 plus or minus the square root of 6 squared is 36 minus 52 divided by 2, and then that gives us 6 over 2. Let me just divide it, split them up. Okay, plus or minus 36 minus 52 is negative 16 minus 16 square root over 2. Okay, so this becomes 3 plus or minus the square root of Negative is I, and the square root of 16 is 4, so you're going to have 4I over 2. Don't forget, anytime you square a negative number, you go into the, it's gonna become an imaginary number, okay? So if I divide the 4 by 2, I'll have 3 plus or minus 2I. If I split the equations apart, my solutions will be 3 minus 2I and 3 plus 2I. So our answer to this is D, okay? Alright, let's move along to question number 44. It says, clear this page. It says, which of the following most accurately describes the translation of the graph y equals x plus 3 squared minus 2 to the graph y equals x minus 2 squared plus 2. So what I want to do is basically find the vertices, and then I can see how to go from the first one to the next one. Okay, so how do I go from v1 to v2? Okay, so the first equation is y equals x plus 3 squared minus 2. I'll put it in standard form. I'll just add 2 to both sides. In vertex form, sorry. So I'm going to have y plus 2 equals x plus 3 squared. For this one, the vertex v1 is basically going to be the opposites, right? So it's going to be negative 3, comma, negative 2. Okay? And then for the next one, we have the second equation is y equals x minus 2 squared plus 2. So I basically add 2 to both, subtract 2 to both sides. So I'm going to have y minus 2 equals x minus 2 quantity squared. Okay? The vertex here, I'll take the opposite, is 2, comma, 2. Okay? So you basically just take the opposites of the numbers, alright? So now, let's see. How do you go from this to this? The best way to solve a problem like this is to actually graph the points and ask yourself, how do I go from the first point to the second point, okay? How do I go from the first coordinate to the second coordinate? Alright, so let's say that's v1 and this is v2. Let's graph v1. V1 is, you go to the left 3, 1, 2, 3, and then go down 2, 1, 2. Your graph does not have to be perfect by any means. And then to find v2, this is v2 right here, part of my 2, I go to the right 1, 2, and then I go up 1, 2. Okay? So there you have it. So that's v1, that's v2. So how do you go from this point to that point? You must go to the right 1, 2, 3, 4, 5 units to the right. Well, voila, we already have our answer. 5 units to the right, right? And then you're going to go up 1, 2, 3, 4. So 5 to the right and 4 units up will be our answer. So for this one, the solution is A. Okay? Alright, now let's move on to question 45. It says, which of the following sentences is true about the graphs of y equals 3 minus 5x squared plus 1 and y equals 3 minus plus 5x squared plus 1. So if you look at the two equations, you notice that they're basically identical. The only thing that's different in the two equations is your signs. Okay, so y equals 3 times x minus 5 squared plus 1, and y, and then the other one you have y equals 3 times x plus 5 squared plus 1. Okay, so if we want to find the vertex of this one, you just minus 1 from both sides. You have y minus 1 equals 3x plus x minus 5 squared. So the vertex for the first one is basically 5, 1. You do the opposites of the numbers. And then for this one, you subtract 1 from both sides, and then you have y minus 1 equals 3 times x plus 5 squared. And then the vertex for the second one is basically the opposites, negative 5, 1. Alright, everything else is the same. So the graphs are going to look very similar, only that the vertices will be different, okay? So A says your vertices are maximum. So to look at the concavity or the opening of the vertices, we basically look at A. Okay, if A is bigger than 0 or positive, then we have a happy situation right here. We have a happy parabola, and then in that case, the vertex is a minimum. Okay, if A were less than 0 or negative, you have a sad situation where our vertex is going to be a maximum. Okay. So in this case, A is basically 3, right? Because A is right here. This right here is A. That's A for the first one. It's the same thing as the second one. They are both positive, so we're going to have a happy situation, and it's basically going to be a minimum, okay? It's going to be a min. But A says the vertices are maximum, so that's absolutely wrong. Okay, so A is not the answer, so the B1 says the graphs have the same shape with different vertices. That's exactly correct, because everything is the same. The only thing that's different is just the signs. The sign for the coordinates of x and y for the vertex. So everything else is the same, like the intercepts and all that other cool stuff. Okay? So the answer to this one is basically B. Alright, let's move on to question 46. In question 46, it says, what are the intercepts of the graph y equals 12x squared minus 5x minus 2. What are the intercepts? To find the x-intercepts, to be specific, we have to set y to 0, right? So we're going to have 12x squared minus 5x minus 2 equals 0. So if we can solve this for x, that will tell me what the intercepts are, okay? So I can see that I have rational numbers here as my possible results, all real. So I think my x game should work perfectly here. Okay, so let's make our x. I'm going to use the x factor method to do this, or AC method. AC goes on top, B goes on the bottom. A is 12, B is negative 5, C is negative 2. So AC is negative 24, and B is negative 5. So what works? What two numbers multiply to give you negative 24 and add to give you 5? Negative 8 and 3 is a perfect combination that works here. So we're going to go 12x squared, replace the middle term negative 5 with negative 8x plus 3, which is the same thing as negative 5. Break it down the center and factor by grouping. Okay? Alright, so to factor by grouping from these first two, I can take out 4x. That's the greatest common factor. I'll be left with 3x minus 2. And then I can take out 1 from these two since they're co-prime. So I have 3x minus 2. And then these two identical factors, I can factor them out, 3x minus 2. And then what I'm left with, I'll be left with 4x and 1. Just put them together, 4x plus 1, okay? Now I'm going to set these factors to 0 and then basically solve them. So I have 3x minus 2 equals 0, and 4x plus 1 equals 0. This is the zero product property. We multiply two quantities to get 0, one or the other must be 0. Okay, so if I solve this, I add 2 and divide by 3. That'll give me the first x-intercept. So let's go ahead and do that. If I add 2, I'll get 3x equals 2. Close enough. 3x equals 2. Divide by 3. Have x equals 2 over 3. Alright? Oh, voila, we already have an answer. Answer is C. Let me just finish this. Okay, so I subtract 1. I have 4x equals negative 1. Divide by 4. X equals negative 4. So there goes your x-intercepts, 2/3 and negative 1/4. So your final answer is C. Okay? Alright. Let's move along to question number 47. Question 47. Alright, so I just have to transfer it over here. 47, which is the graph of this equation right here? So to do this one, we can just use the vertex and the y-intercepts to solve this. Okay, so for this one, the y-intercept is this number right here. Okay, the last number, when you set x equal to 0, this whole expression goes to 0, so the y-intercept is 1, okay? So y-intercept is 1, because when you plug in 0 for x, you're going to have I'm sorry, the y-intercept is not 1. Sorry about that. If you want to get the y-intercept, what you do is you plug in 0 for the x. So to get the y-intercept, you're going to do uh, negative 2 times 0 minus 1 plus 1, which is square. So you're going to have negative 2 plus 1, and then your y-intercept is going to be negative 1. Okay? So that tells me that my answer is either C or B. How on earth do I know that? Because if you look at the graph, it cuts here. That's the y-intercept for C, which is negative 1, and that's the y-intercept for B, which is negative 1. If you look at A, the y-intercept is 3. That's no good. And then for this one, the y-intercept is 3 also. That's no good. Okay? Don't forget that minus there. So it's either C or A. So now I've reduced my possibilities down to 2 to find out my final answer. I just need to find what the vertex is, okay? So to find the vertex, I subtract 1 from both sides, and I'm going to have y minus 1 equals negative 2x minus 1 squared. So vertex is basically the opposite of these two numbers. For the x, we have 1. For the y, we have 1. So which one has 1, 1 as the vertex? The answer is, let me see. The answer is C. Okay, is C because the vertex for B is negative 1 1, and the vertex for C is 1 1. See that 1 1? The vertex here is 1 1. That's exactly what I want. This is the answer. That's not the answer because this vertex is negative 1 1. All right. So the answer to number 47 is C. All right. Let's move on to number 48. Number 48, it says, which ordered pair is a vertex of this? So we have 48. I'm going to write y as fx, okay? Y equals x squared plus 6x plus 5. So to find the vertex, we have to complete the square here. And then that should make it easy for us to tell what the vertex is, okay? So before I start completing the square, I have to move the 5 to the other side. So I have to subtract 5 from both sides first. Subtract 5, and then I'll have y minus 5 equals x squared plus 6x. So I need to create a perfect square trinomial on the right side. So what do I add? In order to find a perfect square trinomial or create a perfect square trinomial, you must complete the square. So to complete the square, you need to do b over 2 square. Okay. So in this case, b is 6. And then to complete the square, I have to just divide it and square it. Okay, so 6 over 2 is 3. And when I square that, that's 9. Okay, so I'm going to add that to both sides so that the right side becomes a perfect square trinomial. So I'm basically going to add 9 here and add 9 here. Okay, so we're going to have y minus 5, y plus 4 equals x squared plus 6x plus 9. And then we factor this. To factor this, you're going to root the first and the last. And then you're going to have y plus 4. If you root that, you have x, bring down the middle sign. X plus 3 quantity squared. Okay, so that goes the factored form. So this is the vertex form for this equation. So to get the vertex, we just take the opposite of the x coordinate, negative 3, and the opposite of the y coordinate, negative 4, and the answer is A. Okay, so there you have it. All right, let's move on to question 49. To do question 49, it says the graph of a hyperbola is given there. Which of them is the asymptotes? So with number 49, we're given a hyperbola with center 0, 0. So you have x over 2 square minus y over 3 square equals 1. So since the center is 0, our asymptotes are going to be really easy. They're basically going to be y equals plus or minus b over a x. Okay? Remember, b is basically going to be your rise, Okay, and A is your run. Okay, so when you're rising, you're going along the y-axis, right? That goes, you rise along the y-axis, and then when you run along the x-axis. You run along the x-axis, okay? So in this case, A is the square root of the denominator. The denominator is 2 squared, which is 4, so A is basically 2, and B is the square root of the denominator, which is 9 here, which is 3. Alright, so our asymptotes are going to be y equals 3 over 2. I mean, plus or minus 3 over 2. If we split them apart, 3 over 2x, if we split them apart, we're going to have y equals negative 3 over 2x, or y equals 3 over 2x. Okay, remember the rise always goes on top, b and the run goes on the bottom. Okay, so the answer to this question is A. Alright, now let's move on to question 50. Question 50, it says, which of the following represents a parabola? So for this one, you just need to know the general form equation for a parabola. Remember, parabolas have only one square in them. If you look at A, x squared plus y squared equals r squared. You have a sum of squares with the same coefficients. That's a circle. Okay, that's a circle, right? Anytime you have a sum of squares with the same coefficients, you have, if the biggest powers are both squares, you have a circle. Okay. All right. For B, y squared over a squared plus x squared over b squared equals 1. This is an ellipse for certainty. Okay, this is an ellipse. If a equals b, then we have a special case of an ellipse, which is a circle. Okay, circle is a special case of an ellipse. Okay, well, for sure we know that it's an ellipse. We don't know what kind of ellipse it is. It could be a circular ellipse or an eccentric circle, which is an ellipse. All right, so this is ellipse. That's not what we want. Question C has only one square in it. This is exactly what we want. This is a parabola, okay? Parabolas just have only one squares in them. Remember, y equals x squared, for example, has only one square. That's why it's just like this. Boom. The D1, we have a y squared. If you have a difference of two squares, it's automatically a hyperbola. Okay, so this one is a hyperbola. Hyperbola. Okay, so the answer to this question is C, because parabolas have only one square. All right. Okay, now let's move on to question number 51. Alright, so 51, let's take a look at 51. We have this um, conic section in general form for x squared minus 5y squared minus 16x minus 30y minus 9 equals 0. So we have it in general form, and we have to put it in standard form. So in order to do this, we're going to have to complete the square for both the x's and the y's. So what I'm going to do is I'm going to collect the x's together. For x squared minus 16x, and then the y's minus 5y squared minus 30y, and then this constant, I'll move it over to the right side of the equation, okay? Since this is a plus negative 9, I'll do the opposite, which is add 9 to both sides. This is going to be equal 9. Okay? Alright, so I'm going to complete the square for the x and the y side. So for the x, before I complete the square, I need to make sure that it's easy for me to root the first term. So I'll just factor out 4 from the x component. So I'll have 4 times x squared minus 4x. And then on the y side, I'll take out negative 5, so I'll be left with y squared plus 6y, okay, equals 9. Now, if you take a look at this, for the x component, b is basically 4, negative 4. So for the x, b is negative 4. So what am I going to do with that? I'm going to divide it by 2, and then I'm going to square it. So if I square negative 2, I'll get 4. Remember, if you want to complete the square, you always do b over 2 square, okay? So b for the x is negative 4. You divide it by 2, you get negative 2, and when you square it, you get 4, okay? So for the x's, I'm going to have 4 times x squared minus 4x plus 4. I got this 4 by doing b over 2 square. And then for the y components, I'm going to do the same thing, okay? For 6y. For the y, I'm just going to do b for the y over 2 square. Okay, so for the y side, b is 6. So I divide that by 2, I get 3. Right, that's b over 2, but you gotta square it. So when you square it, 3, you get 9. So I'm going to add 9 here. So what we're doing is we're basically creating perfect square trinomials so that I can factor it into two perfect squares. Okay. So if you take a look at this, the right side we have 9. Since I added 4 here, we have a 4 outside here, so we multiply them together. So I'll be adding 16. And then I have a negative 5 here and a 9. If I multiply these two, it will be minus 45, I believe. Yes, minus 45. Okay, so if I factor this, I'm going to have 4 times. When I root the first and the last and bring down the middle sign, I'll have a x minus 2 square minus, and then 5. Same story here, just root the first and the last, bring down the middle sign. You're going to have y plus 3 square equals 9 plus 16 is 25 minus 45 is 20. Negative 20, I'm sorry. Alright, so in order to put this in standard form, this has to be equal to 1. Okay, so in order to make this equal to 1, I have to divide everything by negative 20. Okay, divide everything by negative 20 so that I can make the right side of the equation equal 1. Divide that by negative 20, divide that by negative 20. Alright, so that yields for us 4 goes here 1, 4 goes here negative 5. 5 goes here 1, 5 goes here 4. Since they're both minuses, these two become pluses, right? Because minus over minus is plus. So since this is positive, we might as well put it in front. So we're going to have y plus 3 squared divided by 4. This minus, we can put it right here. Minus x minus 2 squared divided by 5 equals 1. There goes your standard form. So your answer for 51 is B. Okay. All right. Now let's move on to question number 52. 52 says, where are you? It says, which statement describes the graph of the equation x squared plus y squared minus 6y minus 3 equals 0? Same thing as what we just did before. This is a conic section in general form. We're going to put it in standard form and see what conic it is. Okay, so just by observing it, if you look at the squares, they will have the same coefficient and the same sign, so that automatically makes it a circle. Okay, so the answer is going to be C or D. We just got to figure out what the radius is. Okay, it's not a hyperbola because the squares are not being subtracted from each other. Okay, so in order to complete the square for the x and the y, we're going to collect them together. Okay, so we do the x squared and then plus 4x, put the x's together. And then the y squared minus 6y, put them together, and then this constant, just toss it to the other side by doing the opposite, which is adding 3 to both sides, okay? Alright, so for the x, I'm going to do b over 2 squared. So b for the x side is 4. So I'm going to divide it by 2, which is 2 squared, which is 4. So that completes the square for the x part. So I'm going to have x squared plus 4x, and then plus 4. And then plus on the y side, y squared minus 6y. I'm going to do b over 2 squared again. Okay, so b for the x part is negative 6. Divide by that by 2, you get negative 3, and then y squared to get 9. So that's why I add on to the 9 to the y side to complete the square. You notice, like the previous problem, I did some factorization, but here there's no number in front of the square, so I don't need to factor out anything. Okay, so on this side I'll just add 4 and add 9. This one factors into x plus 2 quantity squared. Remember, just root the first and the last and bring down the middle sign, okay, for the x part. And then for the y side, just root the first and the last, bring down the middle sign. You're going to have y minus 3 squared. 3 plus 4 is 12 plus 9. Wait a minute. 3. We did 3 is 4. 12 plus 9 is 6. Did I make a mistake here? Let's see. Alright, so 3 plus 4 is not 12. 3 plus 4 is 7. 7 plus 9 is 16, okay? So we have that. Okay, so this is clearly an equation of a circle. So the center, you do the opposite of these two. The center is negative 2, negative 2, positive 3, because you do the opposites. So it's either C or D, because those are the centers indicated there. The correct conic section, circle, circle. What's the radius? The radius is basically the square root of the number you have on the right side, okay? So square root of 16, which is 4. Alright, so the answer is D. Okay, let's move on to question 53. It says, what is the solution of the equation 5 to the x equals 17? So 53, 5 to the x equals 17. Well, I'm going to use logarithm to get rid of this exponent. So I'm going to go log base 5 of 5 to the x equals log base 5 of 17. This to cancel out, so you're going to have x equals log base 5 of 17. Using the change of base formula, you know log a over, log a base b. Alright, let's say log a base b is basically, if you want to have a target base of n, is basically log base n of a over log base n of b. This is called the change of base formula. Okay, so how do I change this base into the target base? The target base here is 10, as I can see here. So basically, the top, this number right here goes into the numerator. Log base target base is 10 of 17. And then the original base goes as the bottom, 5 base 10. Okay? So n and n in this case is 10 and 10. 17 goes on top and 5 goes on the bottom, just as a went to the top here, and the base b went to the bottom here, and then your target base n and n were the bases here. So this is 10 and 10, that's your target base. So log 17 base 10 over log 5 base 10 is your final answer. Okay? So this answer is D. Alright, let's move along to question 54. It says, find the value of x if log base 10 of x equals negative 2. So I want to get rid of this log right here. So I'm going to exponentiate both sides using 10 as the base. So I'm going to have 10 to the log base 10 of x equals 10 to the negative 2. Alright, so these two cancel out. And you're going to have x equals 10 to the negative 2. Negative reciprocal basically means you have to reciprocate. Okay, so 10 to the negative 2, we can put a 1 here. You reciprocate that, you have 1 over 10 squared. 1 over 10 squared is basically 1 over 100, and there goes your final answer. Okay, so the answer for number 54 is C. Alright, let's move on to question number 55. Question 55, it says which equation is equivalent to log base 3 of 1 over 9 equals x. So this one I want to get rid of the log here. So I'm just going to exponentiate both sides using 3 as a base. So 3 to the log base 3 of 1/9 equals 3 to the x. Okay, so these cancel out, and I have 1 over 9 equals 3 to the x. I could switch it around and just write 3 to the x equals 1 over 9 because of the reflexive property of equality. So our answer here is C. Alright. Okay, let's take a look at number 56. Number 56, basically what is true if log base x of y equals 2? Well, these options have the logs taken care of. The logs are not there, so I need to get rid of this log. So to do that, I'm just going to use the base. X as a basis for exponentiation. So I'm going to have x to the log base x of y on the left side and exponentiate put the right side using x as a basis square. Okay? So these two cancel out. So you're going to have y equals x squared as the answer. So that matches option A. Alright? Alright, let's take a look at question 57. Error analysis here, trying to find mistakes. So it says, which is the first incorrect step? Some questions ask for correct, some ask for incorrect. So this one says, what is the first incorrect step? So let's work out the problem and see where the mistake is. So if we have log base 4 over 64, since we're subtracting, we're going to be subtracting. Since we're dividing, we're going to be subtracting the bases, right? So let's go ahead and do that. So we're going to have log base 4 minus log base 4 of 64. Good, they got it right. Now, in order to simplify this, these two cancel out to 1, right? Because they match. So these two is basically 1 minus, what is log base 4 of 64? We know log base 4 of 64 is log base 4 of 4 to the third, right? Because 4 to the third equals 64, right? So these two cancel out, they just left with 3. So it's supposed to be 1 minus 3, okay? But here you have 1 minus 16. I think they divided, which is wrong. So the wrong step 2 is absolutely wrong. So your answer is B. Okay? Alright, let's move along to question number 58. Question 58. We're analyzing 4 student work and we're trying to find the correct one. Which of them is correct? So why don't we just do the problem and see who gets what we got. Okay, so the question is basically x to the third times x to the negative 7. Now, if you have a negative reciprocal, that negative exponent, that component must be reciprocated. Okay, so x to the third stays upstairs. Since x to the negative 7 has a negative exponent, it's ill, so it needs to go downstairs. All right, so it becomes x to the 7. Boom. All right, let's see who already messed up. 1, 2. Jeremy and Michael are already out of the question. Okay, so it's either Shannon or Brenda. Now let's see who got it right. So to finish this up, you basically subtract the smaller one from the bigger one. Okay, so the smaller one is going to be subtracted from the bigger one, power. So it's going to be x to the 7 minus 3. Okay, and then your answer is going to be 1 over x to the 4th. So who's right? Shannon is correct. Okay, she messed up because she took the bigger one to the smaller one, which makes no sense. The bigger one is the boss, right? So you always take the smaller one, subtract the smaller one from the bigger one. All right, so the answer is 1 over x to the 4th. Shannon is correct. Shannon is correct. So that means our answer is C. All right, moving along. Let's take a look at question 59. It says, which is the first, a student showed the following steps in solution, but his answer was not correct. What step did he make the error? Okay, so let's take a look at this real quick. For 59, log base 5 of 2x squared minus 3x plus 1 minus log base 5 of x minus 1 plus log base 5 of 125 equals 6. So what he did first was he proceeded to factor this, okay? So he factored it, okay, that's fine. Log base 5 of 2x minus 1 times x minus 1, let's assume that he factored it correctly, minus log base 5 of x minus 1 plus. Now he changed this one into a 3, is that correct? Well, what is log base 5 of 125? So careful. So this one, 25 is 5 to the third, right? So these two cancel out, so that's perfectly fine. This is 3 equals 6. So step 1 is good. Now step 2, what did he do? He subtracted 3 from both sides, which is fine. If you subtract 3 from both sides, right? Subtract 3 from both sides, and you have same thing, log base 5 of 2x minus 1 times x minus 1 minus log base 5 of x minus 1 equals 6 minus 3 is 3. Good. Now what did he do next? Uh-oh. How do you go from here to here? If you're subtracting, you want to divide the logs, right? So log base 5 of 2x minus 1 times x minus 1. This piece right here should be divided by this piece right here, right? So divided by x minus 1. So if you divide that, these two cancel out, and you're left with that. Not x minus 1, so that's wrong. So step 3 is wrong. Alright, step 3 is wrong. So that goes his first error. Okay? Alright, let's move along to the last question for this clip, question number 60. says was the first incorrect step in simplifying the expression x squared raised to the third power minus x to the fifth to the negative 1. So first thing you want to do, whenever you have a power, raised to a power, you just simply multiply the power. So in step 1, we have x to the 6 minus x to the negative 5. Is that what they got? Yes, good job. That's good. Now next, if you have a negative exponent, you have to reciprocate the power, right? You have to reciprocate the term. So x to the 6 stays the way it is. This one gets reciprocated to 1 over x to the 5th because the power is negative. And that's what was done here. Excellent. So next thing we're going to do here is we need to find the LCD and combine these two terms, okay? So we multiply by x to the 5th, top and bottom here, because that's what the denominator LCD is. And then here we just multiply by 1, So we can have x to the 11 over x to the 5th minus 1 over x to the 5th, which basically gives us x to the 11 minus 1 over x to the 5th. What did he do here? Oh my goodness, he messed up. I think he just multiplied across. So step 3 is wrong because he failed to look for the LCD before even combining these two. If he did that, this is what he's gonna get. Okay, I got 11 by adding 5 and 6. So step 3 is incorrect. Okay. All right, thanks guys for watching this clip. Do subscribe to my videos for more updates. Hope this helps you get ready for your CSTs.